Yeah. Good morning and good evening, everyone. Welcome back. In our last session, we discussed about few concepts, that is for each, and then dynamic blocks and Terraform remote state. Okay. Yeah. So we discussed state and remote state. From today onwards, we will store everything into the remote state with DynamoDB locking, and then for each, and then dynamic block. Okay, so these three concepts we discussed, and today we will discuss TF-VARs. Okay. What is that TF-VARs? So in Ansible, what I said generally, Ansible configuration code is same, but how can we use same code to configure multi-environment? Okay, so like dev and then production. So the only difference is you can control this through the hosts and different variables. Okay, so this is the technique generally. So the code is same, only the difference is the target host you are doing, the host you are targeting, and the variables particular to the hosts are different. So like this same concept in Terraform. Okay, so let me copy first provider. Here provider, I'm saying the key here is TFS, and you can keep whatever key you want. Okay, yeah, so into the same S3 bucket and DynamoDB table. So similarly in intra IAC also, to maintain consistency across environments, multi-environment, we can use same code but different variables. Okay. So that is the general technique. If you see here, now let us say the use case, we need 10 instances in dev and 10 instances in prod. Okay, and Route 53 records also. How those Route 53 records should be now here is like MongoDB -dev. So, and then MongoDB -prod. So like this, we need Route 53 records, and we need 10 instances in dev and then production. So we are creating dev and production infrastructure both with similar same code. Okay, how can we control that here is, so let me have the instances.tf. Okay, so we have the code already. We take from for each. So we have AWS instance, and then RoboShop var.instances, and each.value. Okay, so variables we will have, right? Variables.tf. Okay, so variables.tf, just copying it. Okay. So these are our variables. So this is our AMI ID. So this is instances, and zone ID, domain, and ingress. Okay, let me create one security group also. This is our security group code. Count. variables. This is the security group code. I'm keeping it again. Allow all, and then security group name, can keep it here. Security group name, and then default, I'm keeping it as allow all. Let me remove this, don't need. And what else? CIDR. Default. Okay. So let us get the documentation. Terraform. You can go here, registry, and then providers. We are using AWS provider. Documentation, AWS _security group. So, excuse me. Yeah. So here CIDR blocked. So everything is fine. Security group is fine. And then instances are fine. Okay, everything seems fine. Now let us go for init. Terraform init. Okay, so it will initialize to S3, not local now. So if you see this, these are the default variables. Okay, so we can always replace the variables like you have seen in Ansible. Okay, we have variables at different levels where there is variable precedence also. In a similar way in Terraform also. So variables.tf, the values you are mentioning here, these are default values. Okay, values mentioned in variables.tf are default values. We can always override them. Okay, so now if you just do Terraform plan, we need to get the Route 53 also, right? So that is Route 53. Yeah, this is Route 53. Route 53 record AWS instance dot roboshop, and then here each dot key. So now let us create Terraform plan once again. With 21 resources to add 10 instances, 1 security group, and 10 Route 53 records. Okay. So now I want to create infrastructure for dev and then production using the same Terraform code. So generally what we do here is dev one folder and then production one folder. Okay. So I said the code is same, but only difference is variables. So there is a file in Terraform that is Terraform TF-vars. Okay. So this file is used to override the values of default values in variables.tf. So using this technique, you can use this terraform.tf-vars to create infrastructure in multiple environments with the same code. Okay. So the extension is .tf-vars or .tf-vars.json generally. Okay. So how can we keep values? This is how you can keep values. Okay. So let me keep inside dev.tf-vars. Okay. And then inside production prod.tf-vars. Okay. So .tf-vars should be the extension generally. And in production.tf-vars. So okay, you have variables.tf. So you can override these values. This is the default value. This is not the actual value. You can always override this value using .tf-var files. Okay, anyhow, we are using same AMI ID for dev and production, and we will override this one variables instances dot. This instances we will override. Okay, for example, dev we can keep it same, but production let us take large instances. Okay, maybe t3.large and then t3.large here and here t3.medium. So production traffic is more, so that is why I'm taking little bit high instances. Okay. So in production, we have all the instances t3.medium and then MySQL and MongoDB t3.large. Okay, so these are the values. Oh, sorry, this is not like this. So this should be like this. Instances equal to this one. The variable is already declared. Here you no need to declare again. Sorry. So this is the map. Okay. And then in production, instances. Okay, only value here, no need to declare the variable again because variable is declared already here. Okay, zone ID is same, domain is same, and then yeah, security group. So what I can keep here is SG name. So take the security group and then SG name equal to, I'm keeping it as allow all dev. Okay. Similarly, in production, I will keep it another security group, allow all prod. Okay. And here the name should be different. MongoDB -dev. Okay. -dev. Okay. Like this. So our instances names should be MongoDB -dev, MySQL -dev, Redis -dev, so that you can understand by seeing that. So these are related to the dev instances. Similarly, in production, so this should be -prod. Okay. What else we can change? CIDR, we can keep it same. Okay, that's it. So whatever the variables we are changing, I'm keeping it in separate TF var files. Here everything is key value pair. No need of variable declaration. Remember that. And yeah, production.tf vars like this. Okay. So now how can we pass them? Just a simple syntax here is, so there is hyphen vars file. Okay, hyphen var file. So now let us do the planning. Terraform plan hyphen var file equal to dev/dev.tfvars. Okay, var file. Let us see how the instances will come up. Okay, now we can see this security group name. You can see allow all hyphen dev, and then records name web hyphen dev, user hyphen dev, and then shipping hyphen dev. So like this. So what is happening here while running Terraform? Terraform will first see the variable declaration here, and it will check in this TF var files we got any variable value overrides. So we are overriding here the default value. We are overriding here the default value. So this overridden values will be considered, and values which are not overridden, this default value will be considered. Okay, this is a simple technique to control the multiple environment using same code. So using TF vars. Okay. So this file is always used to override the default values in variables.tf. Okay, now we can go for Terraform apply auto approve. Now we'll get the instances. Oh shit, I'm giving default values. Let it create. We need to destroy. I didn't pass the var file. So let us see one more thing generally. I will just try this. So already exists somewhere. Okay, let me destroy Terraform destroy. Okay, so the general way is you can keep terraform.tfvars. So in this case, So this is the default name of terraform.tfvars that will load automatically. Okay. So if you keep the file name as terraform.tfvars, where you have all the TF files, then it will load automatically. For example, now I will keep this as the content here inside terraform.tfvars. Okay, so now you no need to give -var file equal to dev.tfvars. Okay, this will automatically load terraform.tfvars. And then, so this file is always ignored. If you see here, .tfvars. So this file is always ignored because as a developer, I'm writing the code and then pushing it to the GitHub. I am using my own variable values. If other person is using the same code, it is his responsibility to keep his own values. Okay, but the default values, you can always keep it here. If you don't keep it here, then obviously you'll get an error. Okay, so this is terraform.tfvars. This file will not be pushed to the GitHub generally. So this is the user, complete user wish to keep the values whatever he wants. Okay, so now I kept it terraform.tfvars. This means I am making dev as default environment. Okay, you can see this. Now let us go for apply once this is completed. Let me write, not to confuse. Okay, so first thing, variables.tf, you can keep default values here. It is not mandatory to keep default values, okay, generally, but you should declare variable. For example, let me just do something. So this variables dot sd name, I don't want to keep the default one here. I will keep type equal to string. That's it. Okay, I'm declaring variable. Declaring variable, but not providing value. Just observe here carefully. Okay. And in terraform.tfvars also, terraform.tfvars also, let me comment this. Okay, for now. Now let us go for Terraform plan. Now you can see you are getting a prompt to enter the value for sg_name. Why? Because so in variables.tf, you just declared, you didn't give value here. So Terraform is searching in terraform.tfvars. Here also you didn't give anything. So then it has no option except to ask you in the prompt. Okay, you can give here, allow all dev. Or else you can give here also. Now it will not ask for prompt. So terraform.tfvars, it will always replace terraform.tfvars. You can use this to override default values inside variables. Okay. Or else no need to keep default value inside variables. We can directly provide from terraform.tfvars. Okay. That's it. Now I will apply Terraform, apply, approve. Twenty-one resources are getting added. Now you can see we will get the instances with MySQL dev, user dev, and then catalog-dev, like this. Now I want to create the infrastructure for production. So now what is the option I should give? For production, what is the command I should give? Can someone please type also in the chat? So now the Route 53 records also. You can see here Route 53 records, MongoDB-dev, catalog-dev, like this. Okay. Now can someone please type in the chat what is the command I should give here for production? That is apply -var-file equal to prod/prod.tfvars. Okay. So now the variables will be considered from the production folder. That is a simple which again here. So that is because of the name. Actually, we need to keep different state actually. What is this doing? So this is removing the dev instances and then creating the production instances again. Okay, so the problem here is we are using the same remote state. Okay, same backend. Just to show you that, we go to S3. Download this. Okay, so here if you keep the same state, then Terraform is confusing. So this is the RoboShop. The name it refers only this one, and the key is only you have single key. So generally the technique here is different variable values and then different state also. Otherwise Terraform will always replace. Okay, so you need to give different location to store production state. Okay. So now I need to create another bucket. RoboShop remote state and then prod. So create bucket. Create bucket. It should not be capital case. Create bucket. And then DynamoDB. DynamoDB. Tables. Let's create another table. RoboShop locking prod. Partition key should be always lock ID and then create table. Okay. So now let us just search how to give different S3 backend for different environments in Terraform. We have multiple ways. This is workspace. So staging, QA, production generally, and then, so this is the backend. Simple way. Only this one. Once 1 minute. Yeah, this is be provided configuration. We need to make the provided configuration also different, but only this backend. Terraform backend different configuration. Terraform grep config. Terraform plan -- help grep config. Okay, Terraform init config. Terraform init -- help. There should be an option for backend config path. Okay, so this one. So for production, I will keep it backend dot config this one, cutting it. Terraform backend dot tf. Let me make it backend dot tf. Okay, so now Terraform init backend config equal to /backend.tf. Okay, I need to make it only so this one. This is also not required. Yeah. So this is the way. Sorry to make you confused. Now let us make it more clear. Actually, there are multiple ways, multi-environment. So there are 3 ways actually. First way, maintain different repos. So this is the first way. For example, RoboShop-dev is one repo, and then RoboShop-prod is another repo. So in this way, so what is the advantage you have actually? For example, the code is different. Code is completely different. Okay, so this is so that we don't mess with dev and prod. Okay, so this is the advantage. What is the disadvantage of this approach? So you need to work on multiple repos. Okay, code is duplicated in 2 repos. So this is one approach. Okay. So another approach is same thing. Same code, but different variables and config. So this is the second approach. So in this, the pros is code is reused. Cons is you should be very careful while changing because the same code is reflecting to production also. So we have another approach that is Terraform workspaces. We will discuss this in our later point. This is not useful generally. So either you follow the first approach or you follow the second approach. So if the projects are small, like small infrastructure, we can always prefer the second one. Okay, if the projects are very big, like in banking, so and very crucial, then it is always good to maintain two different repos for different environment so that we don't mess with production environment. Okay, so this is a debatable question in interview. So they will ask, how can you maintain multiple environments using Terraform? You need to tell these three ways and you need to tell which way is better. You can always say this is better while working with large projects, and the second approach is better while working with small projects. Okay, and third one also, this is important for interviews, but practically not that much useful. Okay, so we'll see that anyhow later. So the first thing, let me destroy. Destroy. So this is the production backend. What is the S3 bucket here? RoboShop remote state -prod. RoboShop logging -prod. So I'm using this one as dev and this one as production. Let's wait to complete. Still destroying. Destruction completed. So now Terraform, I'm making it as init. So when I say Terraform init, can you tell me? It will be initialized provider.tf, but there is no backend.config here. Okay, let me give backend.tf. So I'm maintaining different backend for dev, different backend for production, different TFVARs for dev, different TFVARs for production. Okay. So now Terraform init backend config equal to dev slash backend.tf. Okay. Let me keep it the default. Backend configuration is changed. Terraform init reconfigure backend config equal to dev slash dev backend.tf. Okay, when something is changed, you need to always go for reconfigure. Now you see in the Terraform folder, there is terraform.tf state. So what is the S3? It is pointing now, RoboShop remote state, RoboShop locking. So this is the S3 it is pointing now. Now, if I want to work for production environment, I need to reconfigure and then I need to mention here prod. So based on the environment you are working, you need to always go for reconfigure. So now the Terraform.tf state is pointing to the production. Okay, so that is the difference. So when you are working generally, so we will do this in Jenkins CI/CD or manual. So now you started working for dev environment, you should always go for Terraform init reconfigure. Why? Because this is pointing to the different configuration and then hyphen backend config equal to dev slash backend.tf. Okay, that's it. Now the state file is pointing to the dev related bucket. Okay. So now I will go for Terraform apply auto approve hyphen var hyphen file equal to dev slash dev.tf. Okay. Nobody will run parallelly dev and production. Okay. Once we test in dev, if it is success, then only we go for production. Now we will get our instances. Instances are getting created. Records are getting created. Okay, so now dev is over. So you tested it, and then now it's just time to go for production. So while going for production, again, you need to re-init this. This is prod backend TF. So now I'm reinitializing the configuration and then pointing it to the production. So now the state file is completely different. So there is no point of messing with dev environment. Okay. So now let us go for Terraform plan. This is prod/prod.tfvars. Okay, now nothing is getting destroyed. We are adding it. So let us go for apply. So that is why I said while using this approach, you should be very careful. The advantage you are getting here is you no need to write separate code, separate Terraform code, but you should be very careful. So now you will get the instances for production. You can see prod, dev, both are running. Okay, 20 instances are running, and then you'll get records also here. Payment-dev, payment-prod like this. So Terraform.tf was generally used to replace the default values of variables, and then you can use this Terraform.tf was to have multiple environments with the same code. Okay, you practice this use case. This is little confusing, maybe little tough, but if you do it multiple times, you will get it full confidence, and then you can tell this properly in interviews. So this is about TF-VARs. So now let us discuss something on modules. So this is the very, very important concept in the Terraform. The power of Terraform lies in modules. Okay. You know the roles in Ansible. Ansible roles. So we have these roles, and then we are calling it from here. So what is this approach? So this approach is, again, don't repeat yourself. Okay. So you create code. Our goal is reuse it. Reuse it instead of writing same again and again. Okay. So now what we do here is, so we will create code. So this is called as modules. Okay. Whenever you need, you can always call modules. Okay. So there is nothing syntax difference, nothing syntax, everything is same, but you will call it whenever you want. So let us create a module for EC2. Terraform module EC2. Okay. So what I do here is I will create a code, the same ec2.tf. So what is the resource definition? Let us go here. AWS underscore instance. Let me take it. Yeah, this one. So we know that, right? Anyhow, we have the code. For example, let me take this one. Of this. Instance type var dot instance type. I'm calling it as instance. So I'm creating one module for EC2 instance. This is the resource definition. You know this already. So what this definition will do generally, this creates EC2 instance in default, generally default VPC. So in variables dot tf variable, I'm giving AMI ID type equal to string, and then variable instance type equal to string. Okay, so this is the module. Okay, the same resource code, instance type you are accepting through the variables. Okay. Now in my RoboShop project, for example, or else let me create one, Terraform EC2. I created a folder here. So now you need to keep the provider. This is the provider. I'm not using the remote locking. For now, let us keep it. And then here inside main.tf, okay, I'm creating it as module and then EC2 instance. Okay, now the source is coming from Terraform modules EC2. Just observe carefully here. I created a folder Terraform modules EC2. I kept the code to create the EC2 instance here. Okay. And then in Terraform EC2, this is the syntax module. What is the name you can give? And then where is the source? So this source is in Terraform modules EC2. Okay. And here you need to provide some values. This is the AMI ID. This is instance type. Okay. So now let us go and then Terraform EC2. Let us go for Terraform init. You can see it is initializing the modules. Okay. So I am saying this is the module, but the actual source code is in this folder, Terraform modules EC2. Now, if you go and check here, you can see in modules.json, it is referring to the Terraform modules EC2. Okay. So now let me make this complete. This modules is a simple topic actually, but many candidates, they found this is very difficult. Let us make it very simple. The concept here is keep the code. Okay, keep code in one folder generally and call it from another repo. Okay, so this is initialized. And now if you give Terraform plan, now it is saying argument AMI ID is required, but nothing is found. Argument instance type is required, but nothing is found. So why is this error? So this Terraform modules EC2, it needs the values for this two. Okay, you are not passing anything from here. So the way to pass here is AMI ID. So what is the AMI ID you want? And instance type. Okay, so what is the instance type you want? Okay, that's it. Now AMI ID, let us give something. So this is the AMI ID. And t2.micro, for example. Okay, so you created module here. So this is the resource definition, and it is accepting AMI ID and instance type. Okay, as a user, you are the user. He is the module developer. He is the developer. For example, I can say Terraform developer, and he is the user. He is consuming, and he need to pass these values. Okay, so now let us go for Terraform plan. Okay, you can see one resource to add. You can go for Terraform apply auto approve. Okay. So now you can start any number of projects. For example, RoboShop EC2, another project helloworld.ec2 and something, but you can always refer the source code for this. Your responsibility is only to supply the values. Okay, that's it. Creating EC2 instance. You have requested VCP capacity than your command allows for the instance. Okay, so it means, so we have already many instances running. So let me terminate them first. Terraform destroy auto approve. -var -file equal to prod/prod.tfvars. Let me take another window. Let me take another window. AWS repos Terraform EC2. Terraform apply auto approve. destroying. So we have 32 cores limit actually by default. So, but we created more powerful instances, right? So that's why we are getting error. So I have given some powerful instances. So this cost is very high. You don't give these instances. Just for demonstration purpose, you can give different instances. Okay. So this charge is very high. If you forget to delete, then that's it. I'm trying to create. It is getting created. So this is how you will write modules. Now you can use the same source code from any number of repos. Just apply the values, your instance will be created. This seems simple right now, but tomorrow when we start VPC and then VPC module development, you will just understand this is very useful. Okay, so you can keep them here in variables. This variables dot tf. You can keep one variables dot tf here and variable AMI underscore ID value equal to, so this one, and then variable instance type value equal to t2 dot micro. You can always replace this var dot AMI ID and then var dot instance type. Okay, don't confuse this variables dot tf with this variables dot tf. Okay, with this variables dot tf. So this is the module developer. So you are the user. For your sake, instead of hard coding here, for your sake, you just kept it in variables dot tf. That's it. Okay, so you are not writing any resource definitions. You are just calling the other module. Someone who already wrote the code, you are calling his code. Okay, so you'll get more clarity from tomorrow on module development, because we are going to discuss VPC and then we will create the VPC infrastructure using modules. Okay, so we can stop till here today, otherwise it may be heavy for today. So you can just go through today and then understand this tf.vars, how we are creating different backend configuration and then different variables, and how can we control the infrastructure using this. Okay, and then module development. So this is a simple module today we tried. Tomorrow it can be more complex. Okay, just understand the flow, how this Terraform EC2 is calling the module and how is it supplying the values. So this variables.tf is different and this variables.tf is different. Don't confuse. So this is for our sake. As a user, instead of hard coding here, you are writing it in variables.tf. Similarly, module developer also followed the same way. Instead of keeping it something, you can always refer from the variable. That's it for today. Any questions? Nishal?
Yeah, hi Shiva, good morning.
Yeah, hi, good morning.
You are creating the S3 bucket, in S3 bucket, creating for development and fraud, right? Creating
Yeah.
S3 bucket and locking with the DynamoDB for individual for development and fraud, right? Is it
Yes.
going to be chargeable while we are keeping that?
The S3
Or
bucket,
maybe-
we have some free tier usage. Just go for S3 free tier usage and then understand how many buckets are free, how much memory is free. DynamoDB may be chargeable, okay, but it has some free tier usage. Just go through it. But we need this. Even it will cost something very less. You can see very less memory. Okay, but we need that. Janardhan?
Yeah, hi Shiva, good morning.
Yeah, hi, good morning.
Actually, I have a couple of questions, Shiva. You said that there are 3 ways that we can maintain the different environments, right? So
Yeah.
you said that the workspace is not, so used in the production, but this is important for interview. That's what you said, right? So
Yeah.
are we going to discuss this workspace, or is it?
Yes, we are going to discuss.
Oh, that's fine. Yeah, I think that I may get clarity more on this once this topic is cleared. And the second question, what we have, Shiva, see, for example, as part of the Terraform blog in the provider blog. So Terraform blog in that, so we are mentioning the version, right? Like, for example, required provider says that AWS is equal to, and then as part of the blog, we are telling the which version. This version will be, somebody will suggest as part of the project, or is it something we can use it?
Yeah, you will decide. Generally, you will use always stable version, right? So 5.15 is released maybe 20 days back. Okay, so you discuss and then decide at least 1 or 2 versions minus from the current version.
So this will be discussed as with the solution architect, or maybe as part of
No, your DevOps and Terraform
we have to
team,
decide
you
that.
discuss, yes.
Oh, okay.
So there will be an architect for DevOps side and infrastructure also, right? So you guys will decide and then you guys will discuss.
Okay, Shiva, no problem. Yeah, and as part of the modules, like we said that a source is equal to modules path we have given, right? So
Yeah.
generally, you said that modules will be maintained as part of the another repository. Correct,
Yeah.
right?
So in tomorrow we will keep it in GitHub and then we will refer it.
Oh, okay then, no problem.
So
thank you.
Till now the development is completed. You can keep it in local. Once the development is completed, I mean module development, you can push to the GitHub. We will directly refer from GitHub.
Okay. And one more thing, Shiva. See, we said that TF-vars file will be used for the passing the values to the main script, right? So as part of the .git ignore, so we are making .tf-vars.
Terraform.tf-vars, correct.
So if we see .git ignore, in that we have mentioned the .terraform, .tf-vars.
Yeah, actually Terraform.tf-vars you can ignore, but
if we ignore, for example, somebody, because anyway, at the end of the day, we are maintaining entire code in the repository, right?
So you can just say Terraform.tf-vars.
Yeah, correct. So we are putting as part of the .git ignore. So which means that this file will not be pushed to the GitHub, right? So
yes.
if it is not there as part of the GitHub, assume that tomorrow some other developer in our same team you clone it. So you will not understand that which values we have passed as part of the previous execution.
I am ignoring Terraform.tf-vars, but not dev.tf-vars, prod.tf-vars.
Oh, okay.
Okay.
So it's all, again, it's like we can customize that which one we wanted.
Yeah, you can always customize, but this is mandatory. This state files, this .terraform, you should never push them to the GitHub.
Okay.
So these are fine. Terraform.tf-vars, this is fine, but generally we are always giving environment specific Terraform.tf-vars.
Okay.
So you can use it for two purposes. One is to override the default values.
Mhm.
Okay. So, and you can use it to control the multiple environments. So Terraform.tfs, there is two advantages. There are two advantages. So one is to always replace the default values, to always override the default values. We can see this in in module development. And another purpose is to control the multiple environments.
Okay. Got it.
So there are
Thank you,
two purposes actually. Yeah.
Thank you, sir.
Alekia Garapati, most welcome.
Yeah, hi, Shiva, good morning.
Yeah, hi, good morning.
Here I'm trying to understand here, we have two multiple ways, right, to use multi-environment concept.
Yes.
So in the first two ways, you mentioned code is completely, here code is duplicated or code is not duplicated.
Yeah,
Code
correct.
difference, do you mean the state, Shiva, or?
This one, I said maintaining different repositories, right? So in that case, what you do generally, so RoboShop, you create RoboShop dev, and then you create another repo, RoboShop prod. Okay. So now there is clear separation. So you will give different bucket, different key there. You will give different bucket and different key here. So different code, everything is different.
Okay. Okay, in the second way, we are duplicating, we are not duplicating the code, but we are copying the state.
We are using the same code, but different state. That's it.
Okay.
Okay. So this one I no need to tell you again, because this is completely different.
Okay. And one more question is, when we are creating multiple environments, actually every time we have to change in the backend, we have few comments, right? Init.
Yeah, you should always reinit this. Otherwise, your bucket will be pointing to the different one, right? So actually, this we do it from Jenkins. Okay, till that time, you try to understand these comments.
Okay. So from using a single time, we can't update multiple environments. Like you already mentioned, like dev and prod, we won't do it parallelly. But if we want to do, is there any chance, like creating multiple dev environments?
Then multiple locations you clone. So you have different take different one. So in the keeping it in single repo, the same code, you cannot parallelly do that. Okay, because it is pointing to the different bucket.
Okay.
So if you do it like this, okay, you can do. Generally for big projects, I suggest this approach, first approach. Small projects, I suggest the second approach. Okay.
Thank you. I got it.
Yeah. So if no questions, maybe today's topic is a little bit complex, but definitely you should practice and then understand. That's all for today. See you in tomorrow's session. And tomorrow,
Shiva, I have a question. One more thing. I think, see, in the previous one of the example, we have created multiple. We have created the security groups, but I think security group is not mentioned in the as part of the instance in the previous codes. If you see, in today's class also, yeah, not this, not the module section. The previous one, TFVARs, we have created, right?
Okay.
If you see the main.tf, yeah. This is the variable.
Yeah. What is different here?
Instance declaration is there, right? Resource declaration, for instance.
This one, okay.
No, this is the variables, right? This is the values we are passing. I'm talking about the main code. So if you see instance at the above, the first one, resource AWS underscore instance, I think we have created the security group, but we have not mentioned the security group here, right?
It's fine, but you can always mention.
Okay.
Yeah. Thanks so much. Have a nice day. See you in tomorrow's session. Bye-bye.